Hello, in this video, we will use an example to demonstrate function abstraction and stepwise refinement. Function abstraction is achieved by separating the use of a function from its implementation. Let's look at this diagram. This is the function. Here's the head of the function. The body is in the black box. The user does not need to know how a function is implemented. So that's here why it is in a black box. All the user needs to know is the function header, how to use the function, how you use the arguments to invoke the function. You have used many Python's built-in functions. You used this in client programs. So you have used print, random, time, all the math functions. All of those functions, you don't know how they're implemented. So you know how to use it through the function header. The concept of function abstraction can be applied to the process of developing programs. When writing a large program, you can use the divide and conquer strategy, also known as stepwise refinement, to break down the problem into subproblems. The subproblems can be further divided into smaller, more manageable subproblems. We're going to use this example, the calendar example, to demonstrate divide and conquer strategy. Suppose you write a program that displays the calendar. So this is the calendar here. You're going to enter the year for the calendar and the month of the year. So the program displays the calendar for the month. If you have this input is 2028 for August, click this button to show the output. So this is the output for August 2020. Today is Saturday, August 8th. Now let's see how we're going to write this program. How would you get started writing such a program? Would you immediately start coding? Beginning programmers often start by trying to work out the solution to every detail. Although details are important in the final program, concern for detail in the early stages may block the problem-solving process. To make problem-solving flow as smoothly as possible, this example by using function abstraction to isolate the details from design and only later implements the details. So we are going to look at the problem to print this calendar. The problem can be divided into two subproblems, is to read the input for the year and month, and then print the month. Reading input is simple. Read integer for the year, integer for the month, and print month. There's more things to do with print month. Print month can be divided into print month title and print month body. Print month title, we need to know what is the month name. So we need to get the month name. Print month body, we need to know what is the first day of the month. And we need to know how many days are in the month. So this is divided into get start date to get the number of days in month. So how do you find the start date? Now let's assume that we know one day in the history, that's January 1st, 1800 was Wednesday. That's the start day for January 1st, 1800 is Wednesday. You can now compute the total number of days between January 1st, 1800 and the first date of the calendar month. So that is what we need to get the total number of days. To get total number of days, we need to know for some year is a leap year, that is 366 days. So we need to get this information. And we also need to know, get the number of days in months. Look at so this is the January, February, March. And for February, it's a leap year. And that is 29 days. For non-leap year is 28 days. So we break this problem into this problem to find is leap year and the problem to get number of days in month. And we're going to put all this together in this big picture is this print calendar. And this is divided into read input, print month, and print month is divided into print month title and print month body, and print month title is divided into this get month name. And so all this for print month body, we need to get start date. And for the getting start date, we need to get the total number of days. And for this getting total number of days, we need to get the number of days in months and test if a leap year is a leap year. So all these problems now are designed and into these modules. And now we're going to implement it. So we can implement it using either the top down or the bottom up strategy. Top down is this. So we're going to start from the top. So the top is right here, the print calendar's main. So then for things we don't know, we use the stubs. Stubs are the unfinished implementation. So this is the the stub. So here for the print month, and we just put a stub here, it's print year month. And this here, print month title, and we just put a stub here, say, hey, print month title. And so we put all this stubs and here. And this is the main, and here the main is this, get the input from the user. So that module reading the input, this is simple enough, does not need to have its own function. So we can combine it with the main function. So here's the main function, get the year and get the month, and now invoke print month. So we're gonna work from the top down and go a little at a time. So implement one at a time, and eventually we get all the module implemented and the whole system is implemented. Now, if you use another approach, bottom up, is look at the bottom. So you're gonna write the bottom and implement it as leap year and write a test program for it, and then implement get number of days in months and write a test program for it. So going up all the way, you have everything done, and when you get to the top. This is the complete program, print calendar. Please study the detailed implementation for the complete program. Let's look at the benefits of the divide and conquer strategy. It's also known as stepwise refinement. Stepwise refinement breaks a large problem into smaller manageable subproblems. Each subproblem can be implemented using a function. This approach makes the program easier to write, reuse, debug, test, modify, and maintain. So we're going to get a simpler programs. The print count in the program is long rather than writing a long sequence of statements in one function. Stepwise refinement breaks it into smaller functions. This simplifies the program and makes the whole program easier to read and understand. Reusing functions. So we have this isLeap function implemented. This function is used in other functions in the get total number of days and in the get number of days in months. So you write it once and you reuse it multiple times. Easier developing, debugging, and testing. Since each subproblem is solved in a function can be developed, debugged, and tested individually. This isolates the errors and makes developing, debugging, and testing easier. Better facilitating teamwork. Since a large problem is divided into subproblems, the subproblems can be assigned to programmers. This makes it easier for programmers to work in teams. That is all for this section on function abstraction and stepwise refinement. Thank you for watching. See you on the next video.